Good morning, class, and welcome to this lesson on Kinematics 3 instantaneous versus average velocity. Today we will compare and contrast instantaneous and average velocity. So you can tell in these kinematics videos, we're just kind of taking things that we already know and comparing them and pairing them up with something, so that way we can have a good basis for what we're learning here. So average velocity, average velocity. Well, average velocity is exactly what we defined it as, average velocity. We can put a little vector arrow of that, is the change in x over the change in t, okay? It is the displacement over the elapsed time, okay? The displacement over the elapsed time. So it is an average velocity. So let's say, for example, just to give you a good example here, if we start off in good old Beaumont, okay? If we start off in good old Beaumont, and we'll just assume for now that is a straight shot to Las Vegas, okay? This would be the displacement from Beaumont to Vegas, okay? And that's about 245 miles, okay? If we drove that in about 4 hours, we would we would have an we would have an average velocity of about 60 miles per hour, okay? Approximately 60 miles an hour, okay? So that would be average velocity, our total distance over our time. But let's just say, because this might happen, if you made this drive, you might find that from Beaumont to about, I don't know, Barstow, you might find there's some traffic, and you might be finding yourself going slower during this part of the drive, and then you might find yourself going faster during this part of the drive. Okay? And so what's going to happen is, maybe you were going like, 30 miles an hour here, and then you're going 90 miles an hour here to catch up, and end up averaging to 60 miles an hour. Now I know the math doesn't work that way most of the time, but I'm just making it simple for you. So, you know, if a cop saw you about right here and you were going 90 and gave you a ticket, he's giving you a ticket for your instantaneous velocity, how fast you were going at that moment, okay? Not for your average velocity. Your average is still going to be about 60, okay? Let's say this trip still takes about 4 hours. Your average is still 60, but it's not your instantaneous. So the instantaneous in math terms, and for those of you who have not taken calculus yet, this might look a little crazy right here. But the instantaneous velocity is the limit, as the limit of the change in x over a change in t. As delta t approaches 0, this is our instantaneous velocity. So we are not going to be using calculus in this course per se, but what we're trying to say is, as the change in time gets smaller and smaller and smaller and smaller and smaller, okay, we don't want 4 hours. We want more like, 1 second, So how fast are you going at that specific second in time is going to be our instantaneous velocity. And so you have to realize the main point of this video is very simple. You have to read the questions you are given. Please read the questions, because there is a difference between average velocity and instantaneous velocity. If the question is asking you, or if you need to use the instantaneous velocity, instantaneous, if you need to find the instantaneous velocity, do not use don't use that equation. We're going to have different kinematic equations that we can use, that we can have instantaneous velocity, but you can't just see the word, you can't see the word velocity and automatically just go boom, delta x over delta t, okay? There are different equations we can use. It's not going to be the limit equation here, but you're going to see those equations here in a little bit, okay? So just be careful when you're reading questions and make sure that you have that you understand what you're actually trying to answer.